being publicly streamed.
Okay, so let's start with Euler's formula. So you guys know if we have any complex numbers, so suppose I have a complex number a plus iota b, then for this complex number we have a polar form, right? Polar coordinate form, which can be written as r of r of cos theta plus iota sin theta, right? So here what is an r? So we know that if we have any complex number, then that complex number we can plot over a complex plane. So this is our complex plane. So over a complex number, we have over a complex plane, we have two axes. One is the imaginary axis and another one is the real axis. So what we do, we travel the distance say over the real axis and mark a point here. And we also travel a distance over the imaginary axis, the distance b, and we mark here. So whatever the intersection point here we got, that is our point a comma, or we can write it as a plus iota b. A plus iota b. So that's how we can represent a plane, represent any complex number over a complex plane, right? So also we know that for any complex number, we have a polar coordinate form. This is our polar form. So in polar form, there are two things. We know what is an r is, we know what is an theta is. So r is nothing but the under the root of a square plus b square. So where a plus iota b is our given complex number. So for any given complex number, if you want to find out the r, so r is nothing but under the root of a square plus b square. And what is an angle theta? So theta is, so suppose we have a point here. So suppose this is our point a plus iota b. So then what we can do, we can compute this particular distance. Okay, so this distance is nothing but r. We can also figure out how we got the formula under the root of a square plus b square by just creating a right angle triangle over here. So if you create a right angle triangle, we know that we have traveled a distance b over our imaginary axis. So this length will be b, and we know that we have traveled a distance a over the real axis. So that means this length is nothing but a. So using Pythagoras theorem, we know that the value of r is nothing but under the root of b square minus or a square plus b square. Right? You can take b square plus a square plus b square. So this is known to be the value of r for any complex number which is given in the form a plus iota b. Right? So we were talking about the angle theta. So what is an angle theta? So angle theta is that angle which were found with which will we can find out this angle by finding the angle between the line which connect the origin 0 comma 0 to our given complex number and this real axis. So here you guys can see this angle over the anti-clockwise angle. So this angle is known to be theta. And also we can have a relation between the theta and the values of a and b. Okay, so you guys know what is the value of tan theta is. If we have a right angle triangle, then the value of tan theta is nothing but the front side upon the base, right? So here the value of tan theta will become b by a, right? Because this is the value of b, this is the value of a. I mean, this distance is b and this distance is a. So that's why if you find out the value of theta, so theta is nothing but b by a. Sorry, tan theta is nothing but b by a. So now what is the value of theta here is? So value of theta is nothing but tan inverse of b by a. Okay, so but there are certain restrictions over here when we use this particular formula, that that theta is nothing but tan inverse of b by a. The thing is, we have considered this triangle over this coordinate, but what happen if we have a triangle over the coordinate somewhere here? Okay, so then also we can find out the value of theta just by looking at theta is nothing but tan inverse of b by a. Okay, but you have to be a little bit careful that we have considered the angle over the anti-clockwise direction. Okay, not the clockwise direction. We have taken the angle formed by the line joining the origin and the point with the real axis. Okay, so this is known to be a polar coordinate for any complex number. Okay. Hello, am I audible now?
Yeah.
Yeah. So we got that for any complex number, we can have a polar form for that particular complex number too. Now, another thing we know is some power series for sine and cos functions, right? So we have talked about a power series which is related to sine function and cos function, which we can obtain by just looking at the Taylor series or the Taylor's formula for the function f of x is equals to sine x. Okay. So this thing we have learned in the lectures too, that the power series for the function sine x is nothing but x minus x cubed by 3 factorial plus x to the power 5 by 5 factorial minus x to the power 7 by 7 factorial plus and so on. So this is a power series which can represent the function sine x. Similarly, we have a power series which can represent the function cos x, right? So the series for cos x is nothing but 1 minus x square by 2 factorial plus x to the power 4 by 4 factorial minus x to the power 6 by 6 factorial plus and so on. Okay, so we have these two power series and we can obtain this power series just by applying the Taylor's formula, right? So we have a Taylor's formula which says that the value of f of x is f of 0 plus f dash at 0 plus f double dash at 0 and so on, right? So we know the Taylor's formula and we can use Taylor's formula to find out the power series for sine x and cos x. Now we want to learn a formula which can represent e to the power I theta, right? So what will be this we want to understand. But again, for e to the power x also we have a power series. So we know that e to the power x is a function which was defined by a power series for getting a function whose derivative is itself, right? So we have learned this in our lectures. So we know that the e to the power x is nothing but 1 plus x square by 2 factorial plus x cube by 3 factorial plus x to the power 4 by 4 factorial plus and so on. Okay, so now what we will do, in place of x we will substitute iota theta. Okay, so we will take x is equals to iota theta. Okay, where theta is any angle, you can consider it to be any real number or any angle. So then this will implies that e to the power iota theta is nothing but 1 plus iota theta plus iota theta the whole square by 2 factorial plus iota theta the whole cube by 3 factorial plus and so on, right? But we know some identities about the number iota. So we know that iota square is nothing but minus 1. We know that iota cube is nothing but minus iota, and iota to the power 4 is nothing but 1. Okay, so now what we'll do, we'll substitute all these values in our given power series. So let's see what will happen. So then this will implies that e to the power iota theta is nothing but 1 plus iota theta. Now here we will get iota square, right? So iota square means minus 1. So this will get minus of theta square by 2 factorial. Now here we have iota cube. So iota cube will give us minus iota. So this will get us minus iota theta to the power 3 by 3 factorial. And now plus theta to the power 4 by 4 factorial. And the same pattern will repeat, because after this we will have iota theta to the power 5 by 5 factorial, and then we will have iota to the power 6, which can so iota to the power 6 is same as iota to the power 4 into iota to the power 2, right? So it is nothing but iota square, because iota to the power 4 is 1 and iota square is nothing but minus 1. So that means the same pattern will repeat again and again and again. So what we can do, we can actually filter out those terms which includes iota, right? So that means this theta, this term minus iota theta cube by 3 factorial, this term iota theta to the power 5 by 5 factorial, and let's see what will happen. Okay, so this will implies that e to the power iota theta, this can be written as 1 minus theta square by 2 factorial plus theta to the power 4 by 4 factorial minus theta to the power 6 by 6 factorial plus and so on. So that means all even powered terms will have no iota with them, right? So these are iota free terms you can consider. So we'll just group them together, and after taking the iota common, let's see what will be the pattern of the power series. So if you take iota common from all these terms which include iota, we'll get simply theta minus or yeah, theta minus, or we can also take actually we need a sine series here, so sine start with x. Okay, fine. So that means theta minus theta square by 2 factorial plus theta to the power 4 by 4 factorial. So
Math.
yeah,
Uh,
sorry.
uh,
Yeah, it's an odd series. Theta cube by 3 factorial, theta to the power 5 by 5 factorial. So that means this term, and this term we have taken. And minus theta to the power 7 by 7 factorial plus and so on. So we can observe that the above series is nothing but just cos theta, because cos theta is an even function. So the terms or the powers of theta will be even. So that's why this series is nothing but cos theta, and this series is nothing but sin theta. So ultimately we get e to the power iota theta is nothing but cos theta plus iota sin theta. Okay, so this formula is known to be Euler's formula, that e to the power iota theta can be written as cos theta plus iota sin theta. Now, why the Euler's formula is that important? Because using this formula, we can find out any power of or any rational power of any complex number. So before that, let's take how can we find out the nth root of unity? Okay, so unity matlab nth root of 1. So here the question comes that we need to find all those complex numbers which satisfy. So suppose all those complex numbers z which satisfy, if you take z to the power n, you will get 1 back. Okay, so the collection of all those complex numbers are known to be the nth root of unity. So here unity means 1, and nth root means ultimately we are finding out the nth root of 1. So what will be those? Okay, so we can use the Euler's formula to find out what will be the nth root of unity is. Okay, is there any doubt so far? Anything which is not clear? Okay, so let's start with the value of n is equals to 2, right? So we need to find all those z for which z square is equals to 1. Okay, so now this is nothing but an equation type of things. We can say that, okay, z square minus 1 is equals to 0, and z minus 1 into z plus 1 is equals to 0. So here we'll get, okay, z could be equal to 1 or z could be equal to minus 1. So that means there are two numbers whose square if you do, you will get 1 back, right? If you take 1 square, you will get 1 back, and if you do minus 1 the whole square, you will again get 1 back. So for n is equals to 2, the answer is very simple. 1 and minus 1 will be the roots of unity, the second two roots of unity. Now what happens if we take n is equals to 3? So that means we need to find out all those complex number for which z cube minus 1 is equals to 0, or simply z cube is equals to 1, but this can be computed as z cube minus 1 is equals to 0. So here also we will apply the formula for simplifying the cube, right? So we know that this z cube minus 1 also can be written as z minus 1 into z square plus z plus 1. So this is a basic formula for solving a cube minus b cube, right? So a cube minus b cube is nothing but a minus b into a square plus ab plus b square. So we have used this formula here, and we need that the multiplication of these two factors should become 0. So here what are the values of z we are getting? So we are getting from this factor z is equals to 1, and we need a z which satisfy this quadratic equation, which is z square plus z plus 1 is equals to 0. Now for finding out the roots of quadratic equation, we have a Sridharacharya formula, right? We know that x is equals to minus b plus minus under the root of b square minus 4ac by 2a, right? So we can compute what are those values of z which can satisfy this particular quadratic equation. So here the value of a is 1, the value of b is also 1, the value of c is also 1. So we get that, okay, z is equals to minus 1 plus minus under the root of 1 square which is 1 minus 4 upon 2 into 1, right? So this will say that, okay, z is nothing but minus 1 plus minus under the root of minus 3 upon 2. But this minus 3 root minus 3 also can be written as root 3 of iota. So that means here we get two values of z, which is z is equals to minus 1 plus under the root of 3 iota by 2, and z is equals to minus 1 minus under the root of 3 iota by 2. So that means there are actually 3 cube roots of unity. So there are 3 cube roots of unity. So that means there exist 3 complex number whose cube, if you do, you will get 1 back. And those numbers are 1, minus 1 plus root 3 iota by 2, and minus 1 minus root 3 iota by 2. Okay, so here we have these two numbers. So these two numbers are given a very nice name. So we actually denote this number by omega, and we denote this number by omega square, or you can take vice versa also. The properties of omega and omega square will remain same. So you can have a very nice properties over here. So then you can find out what is the value of 1 plus omega square. So I think it becomes 0. And similarly, the value of omega cube, if you do, you will get 1 back. So there are 1 to 2 identities for these numbers, omega and omega square. So what is the omega and omega square? So these are the cube root of unity. So that means if you compute the cubes of these numbers, you will get 1 back. Okay. Similarly, what happen if you take n is equals to 4 or n is equals to 5 or any number in place of any natural number in place of n? Whatever values we will get, those values are known to be the nth root of unity. So for finding a general thing, so how can we compute the nth root of unities in general? So for that, we will use the fact that we can write down the complex number into e to the power iota theta form. Okay. So we know that if you have a unit circle, so if you have a unit circle here, so suppose this distance is 1, and then for any point, we can write down the coordinate of this point to be cos theta comma sin theta, right? So for a point, we can have so many coordinates over a unit circle. So over a unit circle, any point can have a coordinate cos theta comma iota cos theta comma sin theta, or you can write down it as a complex number a plus iota beta, or you can write down this particular point in terms of e to the power iota theta. So these three description we can use for any point which is lying over the unit circle. Okay. So if we have a unit circle, then we know that we have a point over here 1. Right. So this 1 can be written as e to the power 2 pi iota. Right. Because what is the value of e to the power 2 pi iota? So this is same as cos 2 pi plus iota sin 2 pi. And which is nothing but the value of cos 2 pi is 1 plus iota into 0, which is nothing but 1. So that means this 1 can be written as e to the power 2 pi iota. This also, so that means the same 1. So this 1 can be written as e to the power 2 pi iota. This is also this also can be written as e to the power 2 into 2 pi iota, right? Which is nothing but e to the power 2 square, or we can just write it down as 2 into 2 pi iota. This is same as e to the power 3 into 2 pi iota, and so on. Because we know that the values of cos theta and sin theta won't change if we take any multiple of 2 pi, right? So this is same as cos 4 pi plus iota sin 4 pi. And cos 4 pi is 1, and iota sin 4 pi is nothing but 0. So ultimately we will get 1 back. So that means for this one, we can have several representation. It can be written as e to the power 2 pi iota. It can be written as 2 into e to the power 2 pi iota, 3 into e to the power 2 pi iota, and so on. So now what we need to find out? We need to find out what will be the nth root of 1. Okay, so for that, what we will do, we'll just take nth root over here. So we can take this number to be e to the power 2 pi iota into n minus 1. So we have taken n numbers over here. For the first number is e to the power 2 pi iota. Second number is e to the power 2 into 2 pi iota up to n minus 1. Because we know that the nth root will include 1 also. Right. So here we have n minus 1 numbers. and here we have nth number, nth unit root. So that means the nth or the nth root of unity, this can be written as the first one will be 1, another one will be e to the power 2 pi iota by n, another will be e to the power 3 pi iota by n, and the next one will be e to the power 4 pi iota by n, and so on up to e to the power n minus 1 pi iota by n. Okay, so that means here we find out the nth root of unities. Right, just by taking the nth root of these numbers, e to the power 2 pi iota, e to the power 4 pi iota, and so on, because we know that these numbers represents 1 only. So if you take nth root of each number, you will get the n different nth root of unities. So this also can be written in terms of set. So we can say that the nth root of unities, nth roots of unity is what? So this is nothing but e to the power 2 pi iota by k, where the value of k can be ranged from 0 to n minus 1. Or you can take the value of k from 0 to n. So these two sets are same, e to the power 2 pi iota by k, where the value of k is from 1 to up to n. Okay, so these are the nth roots of unity. So for finding nth root of unity, now we have a very nice formula. So we'll say that all the nth roots of unity will look like something e to the power 2 pi iota by k, where the value of k can be ranged from 0 to n minus 1 or 1 to n. Okay, so both are same. So here k cannot be complex. So we have restricting ourselves to take the values of k from 1 to up to n. Now, using this formula, we can actually find out the roots of any complex number. So, for example, if I'll give you one number, so suppose z is nothing but 1 by root 2 plus iota into 1 by root 2. Okay, and if I ask you what is the value of z to the power 3 by 2. Okay, so then how can we compute the value of z to the power 3 by 2? So for that, what we will do, we'll first of all convert this into polar form and then apply the knowledge of nth root of unity. But before that, we have one more formula which is known to be de Moivre's formula, which says that cos theta plus iota sine theta to the power n is actually equal to cos n theta plus iota sine n theta. Okay, so first understand this formula in detail. So what is this formula is? So one thing we know, if you want to find out cos theta plus iota sine theta to the power n. Okay, so suppose I want to find out what is the value of this thing. So but we know that cos theta plus iota sine theta can be written as e to the power iota theta. Then we have to the power n. But here we can use the power rules. So we can say that this is same as e to the power iota n theta. And we can convert this number back to in terms of sine and cos. So this is same as now cos in place of theta. Now we have n theta. So this is same as cos n theta plus iota sine n theta. So we actually use this formula to compute any power of complex numbers. That cos theta plus iota sine theta to the power n is equal to cos n theta plus iota sine n theta. Okay, so now let's get back to our example. So example says if the complex number z is 1 by root 2 plus iota into 1 by root 2, then what is the value of z to the power 3 by 2? So first of all, we will convert this complex number into its polar form. So here we know that the value of r is nothing but under the root of a square plus b square. So here the a is nothing but 1 by root 2. So we have 1 by root 2 the whole square plus 1 by root 2 the whole square, because the value of a and value of b is set. So here we have 1 by root 2 the whole square plus 1 by root 2 the whole square. So which is same as under the root of 1 by 2 plus 1 by 2, and this is nothing but root 1, and the root 1 is nothing but 1 only. So we get that the value of r is nothing but 1. Now the second part is to find the value of theta for this complex number. So here, whenever you want to find out the value of theta, go by the graph. So go by the graph means first of all put this point. So first of all understand in which coordinate this point will lie, and according to that just the value of theta. So for example here the value of a is root 2, 1 by root 2, and the value of b is also 1 by root 2. So that means both values are positive. So it will lie over the first quadrant, right? So here we need to find out the value of theta. So the value of theta depends on the value of 10. So here what will be the value of 10 theta? So the value of 10 theta is b by a. So b is 1 by root 2 and a is also 1 by root 2. So that means the value of 10 theta is nothing but 1. Okay, so this is I have computed by b by a. So for finding the value of accurate value of theta so that you won't miss some signs or something, first of all understand in which coordinate this point will lie. Okay, so here the value of 10 theta is 1. So now for theta there are several choices which you can take to make 10 theta is equals to 1. Okay, so we know that 10 pi by 4 is also equal to 1. If you take the value of 10 pi plus pi by 4, this is also actually equal to 1, because we know that if you remember the formula from your high school, this formula adds sugar to coffee, right? So we know that 10 won't change its nature if you take pi plus, so that means the value of 10 will remain unchanged. So the value of 10 pi plus pi by 4 is same as 10 pi by 4, which is nothing but equal to 1. So when you judge the coordinate, it will help us to choose the value of theta. For example, if you take pi plus pi by 4, the angle will become bigger and the line will be here, right? This will be your angle, pi plus pi by 4. But we know that our point lies over the first coordinate. That's why we choose the value of theta to be pi by 4. Okay. So here the value of theta is nothing but pi by 4. So why I was saying that you first understand in which coordinate your point should lie, so that you can choose the correct value of theta. So that means you have to choose those values of theta for which your point will lie over the same coordinate. Okay, because there are several values of 10 which will give us the same numerical values. For example, 10 pi by 4 is also 1 and 10 pi plus pi by 4 is also 1. So you need to choose pi by 4. So here the value of theta will become pi by 4. Okay, so thus we got that z, which is equal to 1 by root 2 plus iota of 1 by root 2. This is same as r cos theta plus iota sin theta. So r is 1 and here we get cos pi by 4 plus iota sin pi by 4. Okay, now here we can use our De Moivre's formula, which says that this particular formula, cos theta plus iota sin theta to the power n is same as cos n theta plus iota sin n theta. Okay, is there any doubt for finding out the value of theta? How will you proceed? You guys can find out the value of theta for any complex number, right? Is there any doubt?
Yes, ma'am. We can find, no doubt.
Okay. So here we get that z is nothing but cos pi by 4 plus iota sin pi by 4. So we can find out what is the value of z cube. So z cube is nothing but now cos pi by 4 plus iota sin pi by 4 to the power 3. So which is same as cos 3 pi by 4 and plus iota sin 3 pi by 4. We can also take 3 by 2 inside and we can find out z to the power 3 by 2 also. So that means this is same as z to the power 3 by 2 is cos 3 pi by 8 plus iota sin 3 pi by 2. Okay, so that's how we can compute the value of any power of the power of any complex number using the basic formulas that e to the power I theta is cos theta plus iota sin theta and cos theta plus iota sin theta to the power n is equal to cos n theta plus iota sin n theta. Okay. Is there any doubt so far? Okay. So these are the things we have in week 10. So let me recall what are the topics we have covered in week 10. So first of all, we have understand what is the meaning of complex numbers. Right? What is a complex number is, how they can be representation. So in this topic, we have several subtopics. One is the representation, so that contains the polar representation and the coordinate representations. And after that, we have the addition and subtraction of complex numbers. Then we have how to product a complex number, how to find out the modulus of a complex number, and how to divide two complex numbers, right? So these are the things we have learned. So we know that if we have z is equals to a plus iota b, then modulus of z is nothing but under the root of a square plus b square. And we also define what is a conjugate of a complex number is. So the conjugate of a complex number is a minus iota b. And we have a relation between modulus and conjugate, which says that modulus of z is nothing but the root of z into z bar. Okay, so these are the simple identities we have learned in our first part of this week 10. After that, we have a topic which is known to be unit circle and angles in radians, or we can say that a complex plane majorly. So over a complex plane, we have learned that for any complex number, we can represent a point for a complex number by taking one imaginary axis and one real axis. So if you have a plus iota b, we know that this distance is a, this distance is b, and we can represent any complex number over a plane. But more than that, we can relate this complex number with some basic trigonometric function. So we have introduced what are the trigonometric functions are. So trigonometric functions. So we know that if you take the ratio of any two right angle triangles, so suppose you have a smaller right angle triangle and you have very large bigger right angle triangle. Okay, but the thing is this theta is same. So by geometry we know that if you take the ratio of this side with this side, so that means if you take the ratio of, suppose this is OMN and this is some O dash M dash N dash. So geometry says that the ratio of OM upon ON is same as the ratio of O dash upon O dash M dash upon O dash N dash. And we have named this ratio as to be cos theta, right? Because this is base. So cos theta is the ratio of hypotenuse upon the base. So this ratio will always remain same for each and every right angle triangle with the same angle theta. So that's why we have given a special name to this, which is known to be cos theta. Similarly, we know that what is the value of sin theta is. But these functions also we can define by unit circles, right? So if we have a unit circle, suppose this is our unit circle of radius 1, so that is this is a circle of radius 1, that's why it's known to be unit circle. So any coordinate of a unit circle, any point lying over a unit circle, can be thought as having coordinates of the form cos theta comma sin theta. So we can also describe this cos theta sin theta by this way also, but this is same as taking a right angle triangle, because we can form a right angle triangle here, and you can observe that the coordinate of this point will automatically become sin theta comma cos theta. Okay, now after this we have learned some trigonometric identities which you can find out in this PDF too. So we know some basic trigonometric identities, whatever we have learned in our high schools, with the integration and differentiation of trigonometric functions, with the help of also the plotting, the graph of any trigonometric function. After that, we have discussed the Taylor series for sin theta and cos theta. Right. So sin theta is an odd function, so we can take that this is nothing but theta minus theta cubed by 3 factorial plus theta to the power 5 by 5 factorial minus and so on. And the series for cos theta is 1 plus 1 minus theta square by 2 factorial plus theta to the power 4 by 4 factorial minus and so on. So we learned that for these functions, for these trigonometric functions, we can also have a power series. So that means for trigonometric function, you have several type of representation. You can take the help of right angle triangle. You can take the help of unit circle. You can also take the help of their Taylor series too. Okay. So now with the help of this Taylor series and the help of Taylor series for e to the power x function, we have a very nice inequality which says the formula which says that e to the power iota theta is actually cos theta plus iota sin theta. And this formula as well as this formula, that the value of cos theta plus iota sin theta to the power n is actually equal to cos n theta plus iota sin n theta. So using these two formulas, we can find out the powers of any complex numbers. So z cube, z to the power 4, z to the power 9, or z to the power 102. Okay, you just have to figure out how the angle will behave. That's all. So these are the things we have. And the last remark is, so using this formula, we can have a very beautiful equality which is known which is known to be Euler's equality, which says that e to the power iota pi is equals to 1. Right? Because here if you compute e to the power iota pi, sorry, yeah, so this is equal to cos pi plus iota sin pi. Okay, but the value of iota sin pi is 0 and the value of cos pi is minus 1. Right? Yeah, so it says that e to the power uh, iota pi is actually equal to minus 1. So this is known to be most beautiful equality in mathematics. Why is this so? Because it involves so many nice terms. So first of all, e. So e itself is a very good number which comes very frequently in any practical things if you do. So in physics also you have learned so many times you have encountered this particular e. And the second thing, we have a pi, which is also a very big famous thing, which can be defined in several ways. So in our course, we have defined the pi as to be the twice of integration 0 to 1, 1 upon under the root of 1 minus x square dx, right? So in our course, we have defined that a pi is a number, which is the value of this particular integral. But there are also other ways to define the number pi. So that means one can define the value of pi is nothing but a unit area of unit circle, right? We have defined with using the arcane, but there are several descriptions for these numbers, pi, e. But iota is a very famous number, which says that iota is the root of minus 1, right? So this inequality will use so many good terms from maths. That's why it says a very beautiful inequality of mathematics known to be Euler's inequality. So if someone read the Thomas calculus book, they have written about this particular thing in their book. If you go through, you can go and check. Okay, so that's all from week 10. So it particularly includes the trigonometric functions and the complex numbers. So that's all we have in week 10. So let me see if I have left with any topic. Hello, am I audible?
Yes.
Okay. Yeah. So is there any other thing which we have left or any other doubt from week 10? Anything which you guys want to ask? If no, then we'll go to the activity and PA questions. So have you guys attempted any of the activity or PA questions yet?
Not all, few of them.
No.
Started.
It's okay. We will just go through one by one, and then if I think question is very complex, then we can repeat it. Yeah, I'll upload the notes too.
Ma'am, I have doubt in activity number 6.
Activities 10.6.
Yes, ma'am.
Which question? Let me share my screen. So this is 10.6. Which question?
Question number 2 and 3.
Okay, so here what you have to do, you have to use properties of sine and cos function.
Yes, ma'am, that I know, but in the integral,
Yeah, I'll try to solve this one. So suppose here
I
f of
stuck in
x.
some.
So f of x is given to be 1 upon 2 sine x minus 4 cos x, right? So first of all, what is the value of f dash of x? So f dash of x, either you can use the quotient formula or you can use the chain rule also. So the value of f dash of x will become this will become minus 1 upon 2 sine x minus 4 cos x the whole square. And here into we have the differentiation of 2 sine x will become 2 cos x and plus 4 sine x. Right. So I hope this is the value of f dash of x, correct? My screen is visible, right?
Yes, ma'am.
Yes, ma'am. At all.
Now here, what is the value of f dash of x? So we need to find out f dash of 2023 pi by 2. Okay, so first of all, and let's look at this number 2023 pi by 2. We know that we can reduce the cos theta and cos theta sin theta up to some multiple of 2 pi's. So we'll try to convert it into some multiple of 2 pi. So this 2023 by 2, this can be written as some, if you divide 2024 by 2, you will get 1012. So you can take this to be 1012 minus of pi by 2. Right. So if you solve this one, what I'll get? I'll get 2024 minus of pi and also pi here. Right. So 2024 of pi minus pi by 2, which will reduce it to 2023 pi by 2. Okay, and the reason behind this is we want to decompose this 2023 pi by 2 so that we can get some multiple of 2 pi into some angle so that we can reduce cos theta and sin theta. Okay, so let's understand what will be the value of cos theta for this particular number, which is 1012 pi minus pi by 2. Okay, so we know that this number can be written as again some multiple of 2 pi, right? So if you divide this number by 2, you will get 506 into 2 pi. So any multiple of 2 pi won't change the behavior of sine and cos function, because we know that cos 2n pi minus pi by 2 is same as cos pi by 2. Right. So here the value of n you can take to be 506. So this is same as cos pi by 2, and the value of cos pi by 2 is nothing but 0. Is that clear?
Yes, ma'am.
Yes, ma'am.
Right.
It's
Similarly,
clear.
yeah, we can take sine 1012 pi minus pi by 2. This is also same as sine pi by 2, and this is say equal to 1. Okay, so now what we can do, we can substitute the values over here. So this will become minus 1. Cos is 0 and this is 1. So minus 1 into 4 upon sine is 1. So upon 2 will get, and here will get 0. So 2 square will get, right? The square is also there. So I think the answer should be minus 1, but we can check. Is that okay?
Okay.
Yeah. So what you have to do, you just have to make the number in some multiple of 2, right? So that it will get reduced and we can use our known trigonometric identities. Okay. So now let's go to another. So I'll start with P. Okay, practice assignment. So I'll go through one by one questions so that you guys can have a look. So see, I'll just give you hint. I won't solve entire questions. So here in this question, we know that whenever we have a power type of question, we'll go for the formula cos theta plus iota sin theta to the power n is same as cos n theta plus iota sin n theta. Okay. So in this question, I'll give you a pathway. So the first question, practice assignment, first question. So in this question, what you need to do, first of all, convert each and every complex number, that is 1 plus iota, 1 plus iota cube, 1 plus iota to the power 5 and 1 plus iota to the power 7 into polar form. Okay. So after converting that, apply the given formula and some trigonometric identities for addition of cos theta, that is cos a plus b, a minus b, right? All those things you know. So you'll apply that formula and you will get the relation here. Okay, so this is a little lengthy question because here 4 numbers are there. So first you have to convert 4 numbers into polar form and then apply the formula and then equate the quantities. Okay, so you'll get your answer. What does it say? Is that for m comma n belongs to natural number, if z is a real number, then which of the following option is always true? Okay. So now, suppose I'll ask you a question. So suppose you have a real number and suppose you have a complex number z is equals to a plus iota b. And if I say that this is a real number, so that means the statement is the z is equals to a plus iota b is a real number. Then what can you say about the value of b? So suppose z is equals to a plus iota b is a real number. So what does this particular line implies about the value of b? Anyone can guess? So here b should be 0, right? Because if b is not equal to 0, then this number can't be a real number. It will include iota, and if it include iota, it means that it is a complex number. So that means the value of b is nothing but 0. So you also have to use this fact into the question number 1. Okay, so just let's just think about it and do some rough work. I think you guys can get it. Okay, the second question is easy. Just go by our whatever theory or formulas we know for real z into z bar, right? So for real z also, first you need to convert this number into some a plus iota b form and then guess the values of a and b. Okay, so I'll leave this particular question to you guys. And the third question says, let z is equals to x1 plus iota y1 and z to the power 1 by 3 is x2 plus iota y2. And if x1 by x2 minus y1 by y2 is something like this, then find the value of k. Okay. So here what you will do, first of all, what is x1 by x2 and minus y1 by y2 you have to do. So I think it need a little bit of work. So you can compute the value of x1 by x2 also. So which will says that real of what is x1? X1 is real of z. X2 is real of z to the power 1 by 2. So you can go by the polar form. So suppose z is some r cos theta and z to the power 1 by 3 will become cos theta by 3, something like this, and you will get the value of k. Okay. Let me know if this question won't be you guys won't be able to solve. We can discuss it in the next lecture too. So now the fourth question says, if the length of an arc in a circle of radius r units and center angle is pi by 6 is 22 n, then find the value of r. So here you just need to use the basic formula between the radius and arc length, right? We know that if we have a arc length, if you need to find out the value of arc length, and this is the value of theta, this is the value of r. So we have a formula discussed in the lecture, right? It says that arc length is I think theta by r, something like this we have. So you can use that particular formula. Now the fifth question is based on the power. Again, whenever you see the power, just convert the number into polar form, use the formula, we can get the values of power and convert it back, obviously. Right? Now if the complex number z1 and z2 and the origin forms an okay, so we have a triangle, so what is the value of z1 plus z2? So here you need to picture this over your complex plane. So over the complex plane, if you have two numbers, which form a triangle over with the help of origin. Now, what will be the sign of these two complex number, or what are the possible places these two complex number can be arranged? Okay. Now evaluate the limit, integral. Okay, so here I think you need to find out the derivative or something like that, right? So if the race is over in a 1 hour, who won the race and by how much? Okay. So here, obviously, if someone has the good speed, right? If ht is this and tt is this, which are the speed of higher speed, right? Speed is given by some functions. So if the rate change is larger or the values are larger, then obviously those guys will win, right? So you guys can solve this one too. Here you need to find out the relation between omega and omega square. Okay. So first of all, just try these questions. If you guys if you stuck somewhere, then we can help. Because obviously each and every question need a little bit of effort and little bit of thinking. But if you guys won't solve by yourself, how you will guys develop something, right? So it's better just to go by, first of all, just do it by yourself and then we can discuss it. Is that okay?
Yes, ma'am.
Because these are good questions. If I spoil then there's no point. Okay, any other doubt from AQ? So let me check one by one if I don't get any question. Similar question to these questions, then we can solve it. So these are just trigonometrical identities. You can figure these identities just by observing the simpler one. So I have shared one PDF. In that PDF, you have some simpler identities. Apply those identities over here. You can get the form. So I think
Ma'am, I
here
have
by
a doubt.
mistake you have written X. Yeah.
Why integral use Euler form?
Integral means
Like suppose a graph like a parabola. If a complex number is there, so we use Euler form to calculate. Correct.
yeah, because it's simpler, right? So suppose if you have Z is equals to some A plus iota B.
So
Yeah.
what if the parabola limits and it goes to the application of integrals?
Uh, I'm not understanding your question. So your question is why we use Euler formula, right? But what happened parabolas means we don't have parabolas in complex number. What's your
Okay,
doubt,
ma'am, no problem.
Shubham?
It's an off-topic doubt. Leave it.
Yeah. Okay. Fine. So uses of Euler's form because it's simple, right? If you want to find out z to the power 100, you have to multiply 100 brackets, right? A plus iota beta, A plus iota beta, and so on. So if you need to think about Euler's formula, it's easy to apply this. Okay. So here cos root 5. These questions are based on cos and sine functions, right? So here you need some properties about omega function. So if you find out the value of 1 plus omega square. So first of all, find the value of 1 plus omega square, and then you can figure it out what is the value of this bracket is. Okay. So that's your hint. So you can take omega to the power 20 or 10 common and figure it out what is the value of omega to the power 10, omega to the power 23, and so on. Okay. So again, what is the number omega? So omega is any complex number whose cube is equals to 1. Okay. And when we solve this thing, we have got three numbers: 1 minus root 3 iota by 2, 1 plus root 3 iota by 2. So one of them is known to be omega, another one is known to be omega square. Okay. So now activity 10.7. So here we have e to the power theta. So I mean these activities are solvable. So for example, this one, right? So suppose you need to find out the value of e to the power iota 3 pi by 4 plus iota e to the power pi by 4 to the power 100. What you will do? Convert this into sine and cos, and then simplify it and apply the formula cos theta plus iota sine theta to the power n, something like that. Okay. Okay. Any doubt from these questions? These are limits. So okay, so here you need to use the limit extending to 1 of sine x, limit extending to 0 sine x by x is 1, right? So you can use the help of that limit, or you can use L'Hospital rules. Both are workable. So I'm not going through every question. So let me ask if there is any doubt from any AQ. Although if you guys have any doubt, we have a session on Tuesday. You can ask there too. No worries up to that.
Ma'am, will you please elaborate the power series?
Power series? Yeah.
Yes, ma'am.
Yeah, so what is the power series? So in power series, we started with a question that we need to find out a function whose derivative is itself. Okay. So using this restriction, we get some type of intuition that, okay, if we have a series, if we have a power series, or if we have a function, represented by a power series, then that function may help us to find out the answer of this question. Okay, so this is the intuition behind power series. So what is the general structure of a power series is, so any series with this form, that n is ranging from 0 to infinity, a n x to the power n. So you can say that a naught plus a1x plus a2x square plus a3x cube plus and so on. So anything of this particular form is known to be a power series, right? So here we have a two terms. So one is an and another one is x. So what is an an is? So an represent the coordinate of powers of x. So these are the coordinates of or coefficients of x to the power n. So that means what is the coefficient of x square? So the coefficient of x square is a2. What is the coefficient of x cube? So coefficient of x cube is a cube. Sorry, a3 and so on. And what is this x is? So x is variable. So variable means the value of this particular x depend on the coefficients a n. So now in this power series, what are the questions we need to solve is? So the first question is, we need to find out all those values of x. Find all those values of x is equals to x naught, for which if you take
How a
the
complex
series, yeah, just
how
wait
a
a second.
complex number series can converge?
How a complex number series can converge? So we know that e to the power x function, right? So yeah, we can define that e to the power I theta by sine theta and cos theta.
Yes,
It will
that or
converge.
that many more like zn is equals to xn plus I yn and is
Hmm.
equals to 1 to infinity.
Yeah, they will converge because see, ultimately we are getting sine and cos back, right? So because sine
Yes, ma'am.
series and cos series are converging, so their sum is also converged. So you can use that fact. Right. So yeah, so get back to here. So we need to find out all those values of x for which the series summation an, and if you substitute these values in your power series, you'll get an x naught to the power n. Right. Now this is our general series. General series means series with real numbers. Series with real numbers. Right. And we know that how we can find out the convergence or divergence of the series. Right. So in power series, we need to find out all those values of x for which if you substitute those values in your power series, you will get a convergent series. Okay. So for which this series converges. So this is the question we need to solve. But ultimately what happened? Those values of x always lie between an interval. So that means if you take all those values of x for which a given power series converges, that set is nothing but an interval. So ultimately, we'll get some interval type of thing. Okay. So in this interval, we have described a number which is known to be the radius of convergence of this interval. Okay, ROC, radius of convergence of a power series. So radius of a convergence of a power series is that number R for which, okay, so is that number R for which if you take any value of x which is whose modulus is less than strictly less than R, right? Any value of x for whose modulus is strictly less than R, for that value the power series summation a n x to the power n converges. And if you take any value of x for which modulus of x is strictly greater than R, for that number the summation a n x to the power n diverges. Okay, so this particular number R is known to be the radius of convergence for a given power series. And now we have a ratio test to find out this number R. Right? So it actually depends on coefficient C. So this ratio test says ratio test. So ratio test says that the value of R is nothing but the value of 1 by R is nothing but the limit of modulus of a n to the power 1 by n. Limit n tending to infinity. Okay, so here whatever limit you will get, that limit's reciprocal is 1 by R if this limit is not 0 or infinity. So if this limit is infinity, we define R to be 0. So if limit exists and not equal to 0. So and we define that if limit n goes to infinity of modulus of a n to the power 1 by n is 0, then we say that the value of R is infinity. And if the value of this limit is infinity, then we say that the value of R is 0. Okay, so we use the ratio test to find out the value of R for any power series. So I'll repeat what is R is. So our question is to find out all those values of x for which a given power series converges. And ultimately what happens if we have a power series, then those numbers for which power series converges form an interval. Okay, so this result you can observe in higher mathematics course. It says that ultimately we get an interval among which if you choose any value, for that value power series converges, and if you choose any value outside of this interval, the power series diverges. Okay, so for this interval we have defined a number known to be radius of convergence. Okay, so this radius of convergence is a number r for which if you take any value of x whose modulus is strictly less than r, for that value the power series converges, and if you take any value of x for which the modulus of x strictly greater than r, for those values the power series diverges, and we have a ratio test to find out the power series. Okay, now after that what happened? So what we do, so suppose you have a power series, suppose we have a power series, summation, suppose a n x to the power n with the radius of convergence r, right? So now what happened, using a power series we can actually define a function by taking the domain to be open interval minus r to r, right? We can take this interval, this r to be as a part of our domain, and we can define a function whose value is nothing but a but the sum of a power series. For example, we can define a function f of x, that f of x is a function whose value at any point is nothing but at any point x naught is nothing but summation a n x naught to the power n, when the value of modulus of x naught is strictly less than r, right? So what we can do, if we have a power series with some radius of convergence, using that we can define new functions, right? For a function what we need to consider, for a function we need to consider what is the domain and what will be the output you will get. Okay, so for that function we'll consider domain to be all numbers for whose modulus is strictly less than r. Why we are doing this? Because we know that for these numbers obviously power series converges. So for these numbers, we'll define a function whose value at any point is nothing but given by a power series. Okay, and that's how we define that. We can define a function e to the power x from real number to real number whose power series is 1 plus x square by 2 factorial plus and so on. Okay, and this function will give us the answer of e to the power x, derivative is e to the power x. Okay, so this is a summary of power series topic. Any other doubt? Yeah, that's correct. E to the power z is e to the power x into e to the power iota y.
Ma'am, here the meaning of will you give me an example where the differentiation of function will be equal to that function?
Yeah, e to the power x is the only function. I mean, not only, but one of the only functions.
Ma'am,
It's
any another example?
another example. I don't remember now. Any constant multiple of this function, I think it won't work. Because see, if you have a in 12th lecture, we will cover ordinary differential equation. For that differential equation, we need to find a function whose derivative is itself. So what we do, we'll integrate it. Obviously, we'll integrate, we'll get f of x is some integration 0 to x f of t dt plus c, right? So a constant may change something, but ultimately e to the power x, you can say that is the only function whose derivative is itself. Any other function, I don't think it will exist. Yeah, it won't exist. Any other function won't have this property.
So is it just for e to the power x?
Yeah, it is mostly e to the power x because see, sine function, cos function, root functions, all those functions will change if you differentiate it. We won't get fx back. So only e to the power x function satisfy this inequality. Equality. Okay, so let me check once again.
Am I see the if we talk about the complex number convergence through a
Hmm.
circle like a graph, there are so many arbitrary constants like confuse.
Um, yeah, just wait a second.
Like I have example, if z1 is a point inside the circle of convergence, mod z minus z naught is equals to real number of a power series.
Yeah. Just 1 second. Let the next. I don't think there exists any other function that satisfies. Okay. Yeah, there is no other function which satisfy f dash of x is equal to f of x. Yes, what's your doubt, Shubham? What's the Shubham? Someone was talking, no?
Yes, I say that when
Hmm.
we talk about the convergence of a complex number, there are so
No.
many arbitrary constants comes.
Yeah, we actually don't talk about convergence of a complex number actually. So convergence of a complex
Like
number
in a
means what?
series.
Yeah, convergence of series we talk. Yes.
Like if z1 is a point inside a circle convergence, z minus z naught model is equals to real number of a power series. Then we talk about the complex number power series.
Hmm. Yeah, it always
Then if
converges
we
because
want,
see, if you have z is equals to in terms of power series you are writing, right?
yes, ma'am.
Yeah. So see, for z is nothing but power series of cos plus iota sine theta, right? So this power series converges, this power series converges. So if you apply modulus or any continuous operation, see addition, differentiation, modulus, these are all nice operations. They will give you the nice result only. So for example, modulus of z is what? So if z is cos theta plus iota sine theta, the modulus of z is will become 1, right? Because it's same as under the root of cos square theta plus iota
But
plus
the
sine
method
square
I talk about, ma'am, it's an the
theta.
graph method. There is a circle and there is a point of z, z1 and z naught.
Z
Yes.
Z1. Where is this? Z
Uh,
Z1.
g- Ma'am, please draw a circle in first quadrant.
Okay, first quadrant. Hmm.
So the left of the top is z.
Hmm.
Uh, in circle, ma'am, not the
Inside circle.
line.
Okay, okay. Hmm. Zn again.
Then
Yeah, it's all always
the z
converge.
naught
See,
is a yes, ma'am. Okay.
yeah, we can bring back. I mean, you can convert. You can push the circle over here so that it will become a unit circle, and ultimately you can shrink the circle. You can enlarge the circle. Ultimately, you'll get the same result. It
Okay,
won't
ma'am.
affect
That's the point I
the result.
like. It's an confusing.
Hmm.
Okay, ma'am. Thank you.
Yeah, it will converge if you want to see by power series. Any other doubt? Uh, for week 9, we have passed the deadline, I think, right? So I'll ask them to upload PNG solutions. Other than that, is there any technical doubts or anything you guys want to ask? Are the sessions, the sessions are enough for covering the summary and doubts, right? You guys don't need more sessions. Do you guys need some more sessions?
Like
Some
not
problems is
theory sessions, some problems. Yes, ma'am. Some problems sessions.
Yeah, problem solving session we